All right, so the electric field is constant. When the proton enters, or the charge, Q, enters, what's going to happen to it? Talk to me about the forces acting on it.
Forces are going to cause it to move upward.
Okay, which way is the force acting on it? When it's between the two plates, which way is the force acting on it? In other words, hey, force diagram. Woo! And I think, Austin, you just answered.
Yeah, it starts to be moved up by the electric field,
All right, so the force acting on it is,
the electric force.
okay, up. All right, so we got that acting up on it. So we have this electric force acting up. Any other forces acting on it? Because at this point, so last semester we had F tongs. And so now we've got an electric in here, F tongs. Any other forces we need to worry about? All right, Marisol's shaking her head no. Daniel's in agreement, I think. You all supporting Marisol and Daniel? They agree with you. The middle of the room's a little bit hesitant. Kyle, what do you think?
Well, do we have to worry about gravity?
Do we? Do we have to worry about the gravitational force?
I mean, I'd say no, because the mass of the proton not that big.
Yeah.
Wouldn't it be considered negligible? I can't even say the word.
Negligible.
Yeah.
Absolutely, for the reason Daniel pointed out as well. We don't have to actually worry about it. If we were working on our Nobel Prize, you might want to take it into account. But in high energy physics, we ignored it. Matter of fact, if you're working on a Nobel Prize, I think you can ignore it then too. It's so negligible. It'd be for a proton, maybe off the gravitational force is like 10 to the 40th smaller than the electric force. So
Doesn't exist.
close enough for physics.
Yeah, for a Nobel Prize, you might want to list it, but not take it into account for the equation.
Yeah. I was thinking about there was the people who came up with an experiment where it looked like they shot an object faster than the speed of light, which the press got a hold of and said, hey, a particle faster than the speed of light. And the physicist said, this can't be right, where's our mistake? And somebody who was there, who went through their explanation of all the stuff they did, said that was probably one of the most thorough explanations of looking at all the other extraneous factors. So those people probably took that into account. Was told by someone else that there was a glitch in the machine. That's why it appeared that it went faster than the speed of light. If it did go faster than the speed of light, then there's a whole lot of other physics that suddenly you go, that doesn't make any sense why we got the results we did. All right, so that's it. There's our force diagram right there. What is that force equal to?
Is it charge times the electric field?
With a question mark there at the end?
Charge times the electric field strength?
The original question I was asking, absolutely right. At least the question I was asking in my mind. But I'm going to nitpick that. You're close.
What was the question again?
What is the force acting on the particle? What is that force equal to? I think I said.
KQ over R squared.
No, that only works if I've got a dealing with point charge. If the electric field is created by a point charge. Yeah, please don't use KQ over R squared for the electric field if it's not a point charge creating it.
Is it Q times E J hat? Is that?
There we go. So that force, the electric force acting on it, or actually we could just say the total force acting on it, is Q, magnitude of the electric field, J hat. Again, please note, this is the magnitude of the electric field and not the energy. What are we dealing with here? I have this force acting up on it. We've dealt with a lot of problems like this in the first semester course. I should say, very similar to this. I believe it was chapter 4 in the textbook. Again, you didn't study your textbook over the Christmas holidays?
You said chapter 4.
Was that?
You said chapter 4.
I said chapter 4.
Does it have to do with kinematic equations?
It does have to do with kinematic equations. What kinematic equations?
Constant acceleration?
Is acceleration constant here?
Yes.
You don't sound sure. All right, let's take a look at this. Is the charge changing?
No.
Is the electric field changing? I hope not. Yeah, these are constant, this is a constant force, therefore a constant acceleration. These are the cake formulas. It is a two-dimensional problem, which would be the chapter 4 stuff. This is basically a projectile motion problem, except instead of it doing this, it's doing this. So we can break this into horizontal and vertical. What we're trying to figure out is the direction that it's going in afterwards in order to find theta. In other words, we're looking for the velocities, the final velocities. So let's just go down the checklist here. We got displacement, initial velocity, final velocity, acceleration, and time. My horizontal here, this is I hat, and my vertical is J hat. I've already defined up as positive. So what do we know?
Initial velocity.
Okay. Horizontal, let's V sub naught. And vertical?
0.
I heard somebody whisper it. Final velocity is what we're trying to find. Accelerations.
And 0 and the horizon. Is it E?
Would it be E for the vertical?
No, not E. I assume that E?
Yeah.
Yeah, that, not that E. You divided by the wrong thing. We bring in some chapter 5 stuff. The most important equation in all of physics, in my opinion.
I know we're using F equals ma, but I don't know how you apply it to.
So what's the equation?
F equals ma.
Yeah, so that's equal to mass times acceleration. So what's the acceleration
Q E divided by m.
in the j-hat direction? So yeah, so this is Q E over M. And displacement.
Displacement.
Well, horizontal we know. Yep. Vertically, I mean, it does start moving once it enters, and so vertically we really don't know quite yet. So in theory, we know L, V, O. These are all things, all the letters here we know what they are. All right, so that's the stuff that we pull straight out of the problem. We can now take one step further. We do know what the final velocity is horizontally. Say it again.
Is it the same? It's the same.
It is the same, or is it the same?
V0.
So you're making the claim that's V0? You're not sure you want to make that claim?
Yeah, I'm not sure.
Does anyone want to make that claim?
Well, if it's like the other, projectile motion problems, would that be 0?
Oh, that would be 0 you're going for? Is that what you said?
Yeah.
So, if it's 0, that means it stops moving horizontally. There is no horizontal component. At some point, the thing is just going straight up.
Well, it is curving.
It is curving, indeed. If I throw an object out horizontally, at some point, is it going straight down?
No.
Ignoring air resistance, of course. Right, no. So, it won't be 0. In fact, it is V0, but how do you know these are the same thing?
Acceleration's constant,
Ooh,
or it's 0.
yes, more specifically. Acceleration deals with change in velocity. If acceleration is 0 horizontally, there's no change in the velocity horizontally. If you don't buy that, let's just go to the cake formula. Since we are accepting the constant acceleration, Vf equals Vi plus At. I don't care what the time is. If acceleration is 0, that drops out. Those two are the same thing. Is indeed V sub 0. We can now find time. And how do we find time?
Tangent x is equal to VIT. Oh, we don't know horizontal. Oh wait, we do know horizontal.
Yeah, I think you're
So,
correct.
tangent x, VIT. Then divide tangent x by VI.
Okay. I was expecting the plus 1/2 AT squared, but that is 0, so.
We don't need that.
Yeah, you were ahead of me. All right. XS, whatever you're using, is equal to V. I'm going to go ahead and write it down just because it completes me. But that's 0. And so the time is just going to be the distance divided by how fast it's going horizontally. And so we now know this. We can now find VF. Using, well, that equation right there. VF equals VI plus AT. VF is what we're trying to find, so this is 0 plus acceleration, which is Q E over M, times time, which is L over V sub naught. And these are check marks here, this is not L's. Let's do it that way. And that's an L, not a 2. And so we end up with a final vertical velocity, or final vertical speed, however you want to word that one, as Q E L over M V sub naught. Just multiply fractions. Therefore, so we now have this is Q E L over M V sub naught. And so my final velocity is V naught I hat plus Q E L over M V naught J hat. Or written out another way, V naught this way, and Q E L over M V naught that way. and I want to find theta. I know it denied you earlier, but what do we do?
True.
Absolutely. Which trig function are we going to be using?
To find theta,
Yes.
arctan.
All right. So theta is the arctan of Q E L over M V sub naught divided by V sub naught, which we can now write as A tan Q E L over M.
Is that torque, or is that where it'd be considered torque, because it's not cost? On the top, QEL.
No, it's just straight up multiplication, because time, the L over V sub naught is the time, which is a scalar. So it's just a scalar times a vector. Technically, there's a J hat in here, but this is the vertical stuff. The initial speed actually does not affect it. So notice though, I can do something else with this equation. So my angle is the arctan, right, slightly different, Q over M times EL. So if I'm actually conducting an experiment here and I have a whole bunch of particles being shot through here, I just put a bunch of detectors all around here. I see which detector it hits. So now I have a pretty good idea of that angle, so I can actually measure theta. The electric field is something that I can control from a control booth, actually a control room. L is how long these plates are. That is based upon the manufacturing process. I can know what L is. E I control, theta I can measure, and so what I can then calculate Q over M. Q over M narrows down the possibility of what that particle is an incredible amount. That is a relatively, it's not perfect, but it's a relatively unique measuring tool. If it hits up here, I know the particle's positive. If it hits down here, I know the particle's negative. So I can differentiate that. We will also be able to do something similar if in a magnetic field, we can look at when charged particle enters a magnetic field, it will start to curve. If it's in the magnetic field long enough, it will start to curve in a circle. We can look at the radius of that circle, and we can also figure out what Q over M is. But these are powerful tools in order to be able to determine particles that come out of collisions, which is basically my dissertation of smashing protons into I think it was a diamond, and then you get a shower of particles coming out of it, and then the computer did all that stuff. All right, questions to hear?
Why does V0 cancel?
Oh. It seemed odd, but I was going with what I had done there over there. Yeah, oops. Thank you. Double check over here. Yeah, that was, again, heavy machinery, good thing. All right, so V0 does not cancel out, which makes more conceptual sense, but I was letting the math drive my thinking. And V0 we can figure out just by, I'm shooting a particle, I have a detector here, I know the distance between the detectors, I can figure out what the V0 is. You don't have to rely on Precious to catch my mistakes. Other people could do it. Or you just wanna make her the bad guy? No, I really do appreciate it when you point those out.
For some reason, I was just going along with, like, I was just letting the math to drive the answer when it's obvious.
Oh well, might be the worst thing I do today. All right, let's talk quiz, master sets, things like that. Let's see if I can find my calendar. I cannot say what was right here. This one over here. All right, so let's see. So Thursday we've got charge lab due. Next Tuesday we've got the quiz on chapter 23. A week from Thursday, the master set 23 is due, so that's all old stuff. Now let's keep up the pattern. So February 2nd, the quiz on chapter 24. Thursday, February 4th, we'll make master set 24 due.
You physically write that on the board.
You said the fourth, master set Tuesday?
All right, so, and again, get the paper up there. So Tuesday, Thursday, so 120, so 21st, 26th, 28th, the 2nd, and the 4th. All right, so we've got the lab 1 due this Thursday. The 26th this is the quiz on chapter 23. The master set on chapter 23 is due a week from Thursday. Putting the quiz of 24 on February 2nd and the master set for 24 on February 4th. Double checking. So 26th, 28th, 2nd, 4th, okay.
Does the quiz on 23 include the flash?
Yes. So the first part is the flash, and then traditionally we do the flash quiz, get that out of the way, and then answer questions. If someone is not here and we're expecting that person to show up, I might take some questions from the homework textbook first before doing the flash, just because the flash quiz is timed. It's nice if everybody starts and ends at the same time. All right, let's talk about Thursday. There are a whole bunch of labs in that are content appropriate for what we've covered so far later on. There is not an even distribution of good labs for the semester. So Thursday, there is an activity. I will print it out for you and I'll bring it to you. It is quite possible that you will finish it on Thursday and hand it in. It's a series of questions based upon the stuff that we have done so far. So you'll be in a group, you'll discuss it among the group, you'll come out with a common answer, hopefully a common correct answer, because those are so much easier to grade. And so the activity on Thursday I will bring, so you don't need to print anything out. And yeah, there are a couple of labs that I sometimes want to jump into, but we really should do another week of class, get into electric potential before we do those labs. Any questions at the moment?
So we have to email our spreadsheet, right?
Yeah, for the first lab, yeah, I would hope that by the end of Thursday, like midnight, Thursday night, that you will have posted it on Blackboard, the spreadsheet and answers to the analysis questions.
In the analysis questions, you want like a scanned photo, video scan photo?
That works.
So we don't have to turn in anything paper.
Right, I'm trying it out, seeing how it works. Again, I might, after one, I might go, ugh. But I've been encouraged to experiment with this, and so welcome to the science experiment. Or, I guess it's not really a science, welcome to the middle-aged guy working with modern technology experiment.
So what chapter are we going over next Tuesday?
Next Tuesday, chapter 25. Yeah, it's pretty sequential for a while. All right, we could start new material, but I'm thinking in the remaining couple minutes, don't rob any banks because officially you're still in class for the next few minutes. But other than that, be safe. 400,000 dead. Please do not be part of that. Has anyone here gotten the vaccine yet, or at least the first shot? Yeah, I'm not expecting that to happen until probably after the semester's over, but.
It's mostly people that work in healthcare, so they have to.
Oh, so,
People that work in healthcare are the ones that are getting it right now, mostly.
yeah, I didn't know. Sometimes I have students who work at the hospital. I assume Roberto's has his, assuming he's okay.
They're not forced to. People that work in
Have a good
house.
evening.
My dad's a nurse, he doesn't have to do it.
He doesn't have to get it?
Yeah, they haven't forced him to, as of yet.
That sounds like they were limited to supplies. Oh, I'm still recording.